As we're graphing and solving a system of inequalities or solving a system of inequalities by graphing, we may often find or sometimes find that we've got an enclosed region. And if we've got an enclosed region, we're going to have vertices. For instance, as an example, let's just say that we had graph of inequalities, and this is our common solution set right there where they all three intersect. And if you notice, then I've got vertices at each of these points of what in this case is a triangle, but it doesn't have to be a triangle. It could be some other form of polygon depending on how many equations that we've got. Now, in graphing, trying to solve a system by graphing, the first thing that I want to do is get all of the inequality statements solved for y so that I can easily graph those into using my graphing calculator, my TI-84. And so in this first inequality statement here, I don't have to do anything to it. It's already y is greater than or equal to. But in the second one, I've got 2y, and so I need to get this in the form of y. So I'm going to divide both sides of the inequality by 2. And when I do, then I've got y is greater than or equal to 1/2 x minus 8, dividing both the x and the negative 16 by 2. And I can see it's going to be a little bit stranger over here on this third inequality statement. I'm going to need to divide everything by 11. And once I do, I've got y is less than or equal to negative 2 over 11x plus 5 over 11. Now, you may want to jot down those three inequality statements because we're getting ready to move to the calculator and enter each of those, and we're going to be looking for the enclosed region. We should see a triangle. More than likely going to see a triangle, and we're going to find those vertices. And we're going to discover that sometimes I can easily spot the vertices because it happens to line up on a coordinate that's easily recognizable as some whole number or integer. But sometimes I have to drop back and actually take a couple of the inequality statements and solve it algebraically to find a third vertice. So again, jot these down, pause it if you're watching it on your own, because we're now going to head towards the calculator and graph these three. All right, I'm over here on the calculator. I'm getting ready to graph these three inequality statements and try to find the vertices that they create, the solution creates. But before I begin, one of the first things I may want to do is this would be a good idea each time you start to use your calculators. You want to check some things to see if you are set up properly. In other words, depending on what you've been working on last, you may need to change some things. So I'm going to hit second quit, just bring it to the math screen. And I want to first maybe say, is my stat plot on or off? I can't remember what I worked on last. So I hit second y equals, but in my case, I see that it's all off. That's good, because I don't want to stat plot in this case. Another time I may. And then I probably want to check my Windows settings. Oh, and I can see whatever I worked on before was kind of strange. I had some strange numbers. So I'm just going to put it back into the default mode, which x min is negative 10. X max is 10. I want to change that x scale from 20 to 1. I want to do y minimum negative 10. Glad I checked this first. I wouldn't be able to see a thing once we graphed it. Y max at 10. And I want to change the scale, y scale back to 1. All right, so I feel a little better about that. Now I'm going to go into y equal, and I'm going to clear out what I've got, because I'm going to be entering new information. Now, second thing, if you look up here at the top where it says x equals, and about quit app, and right up here in the gray bar where it says Inequality Graphing App, I'm in that Inequality Graphing App mode. That's what I need. And so if you have the app on your calculator, you want to open it up, and you find it by going into apps, because I need it to get my regions. So let's see, my first inequality was y is greater than or equal to. So I'm going to go over here, I'm going to highlight that entire bar, I'm going to hit enter. And I'm going to y where it says y equal, and I want to change that to the greater than or equal to, well, there it is, symbol, and I'm going to enter through here. All right, and let's see, I'm going to go ahead and enter the equation, which was, inequality statement, which was negative 3x plus minus 6. All right, I'm going to move to start on my second one. Again, I need to change it from an equality to an inequality. I'll highlight that entire section, hit enter. And once again, I need a greater than or equal to. And my color of my second graph is going to be red. Enter, enter. All right. And let's see, that inequality statement was y is greater than or equal to 1/2 x minus 8. I'm going to use 0.5 for x, which is 1/2. 0.5 for 1/2. So 0.5x minus 8. So I got my second inequality entered. Now I'm going to go to my third one, which was kind of a bizarre one. I need to highlight this entire thing. Let's see, I'm going to hit enter. And I might want to choose that color. I used a blue and a red. I think I'm going to try green. That's just trial and error. It was in black, which is the third color, which would be okay. But let's see, and this time I need a less than or equal to. So I'm just going to scroll through here, and there's my less than or equal to. Enter, enter, and let's enter that inequality statement, which was negative 7 over 11. So negative 7 divided by 11x. Whoop, got too many ones. X plus 12 over 11. All right, I kind of want to check, make sure negative 3x minus 6, 1/2 x minus 8, negative 7, 11 plus 12 over 11. All right, let's go to our graph and see what we see. There comes my blue, there comes my red, and there comes my green. All right. Now, the common sections, the sections all in the middle, if you kind of follow that cursor, if I can find it, inside this triangle right here is my solution to my system. Now, like I said, some of those I can easily discover what the vertices is. I'm looking for that point, and that point. So let's see, right here when x is negative 1, negative 2, negative 3, y is 1, 2, 3. So one of my solutions is negative 3, 3. And down here, I think I could easily see where it is. X is 1, 2, 3, 4, 5, 6, 7, 8. And y is 1, 2, 3, negative 4. So 8, negative 4 is a vertice. But down here in this bottom, it's not really fitting anywhere particularly. And I'm gonna have to solve a system of inequalities, but I'm gonna be using for that. This is where the blue and the red intersect, or inequality statement number 1 and inequality statement number 2. Now, if I'm having a little bit of confusion seeing where those are, I can go into the table, second graph, and let's see. And what I'm looking for is a value of x that satisfies both, at least 2 of the y's. And so I see right here at the top, when x is -3, y1, which is the first inequality, is 3, and y3 is 3. That is a common point of intersection when x is number 3. That is going to be a vertex. I can identify that as a vertex. And let's see, I thought 8 had one. Let me scroll down to 8. Yeah, when x is 8, y2 is -4, and y3 is -4. So this is another way to recognize where those vertices are. Now, it appeared there's a vertices somewhere between maybe where x is 1, 0. I wasn't sure. See, and I don't see any integer value of x. It's giving me a common x or y variable. And so I'm going to have to solve those on my own. Oh, joy. Okay, so now we were able to determine from the graph and the table a couple of the vertices. In other words, I think we had x is 8, y is -4, and we had when x was -3, y is 3. But I'm looking for that third one. And here I'm going to have to solve this by a system, using the system of equations, and I'm going to use substitution. Since both of these are greater than or equal to, I'm okay there. I'm going to substitute this for y into that inequality and solve it for x. So let's go about doing that. So I would then say 1/2 x minus 8 is greater than or equal to -3x minus 6. Let's add 3x to both sides. Let's add 8 to both sides. So once we do, we'd have 1/2 x plus 3x greater than or equal to, let's see, and positive 8 minus 6 is 2. All right. That's not 3 over x, that's 3x. All right, so I need to add 1/2 x and 3x, and to do so, I need to express that 3x in terms of something over 2, which is 6 over 2. 1/2 x plus 6 over 2x greater than or equal to 2. And so now I got 7 over 2x is greater than or equal to 2. And I need to divide both sides by 7/2, or the same as multiplying by 2 over 7. And so then we can say that x is greater than, let's see, 2 times 7 over 2. And so we're going to then, so for our x coordinate in that third vertices, those are going to, no, got to multiply by 2 over 7. I'm about to screw up, 2 over 7. So x is, let's say, greater than or equal to 4 over 7. All right, so now that I've got that, I'm going to substitute this x is greater than or equal to 4 over 7 into that equation right there, and we're going to solve for y to give us that third coordinate. So it's 4/7. It's a little bit less than 1, greater than 0. That's kind of what I saw in the graph, so I'm feeling fairly good about this. And so let's say then that y is greater than or equal to -3 times 4 over 7 minus 6. Well, y is greater than or equal to, let's see, -3 times 4 is -12 over 7. And to add those together, I need to take that 6 and express it as something over 7. So that could be -42 over 7. 42 divided by 7 is 6. And now I can add those together, and y then is greater than or equal to -54 over 7. And so my third coordinate then is 4 over 7, comma, -54 over 7. A little bit greater than -7, or less than -7, I should say. All right, let's do a couple more. Let's do one more. Solving system of equation using graphing. Once again, I've got 3 inequality statements. I want to get them expressed in something in solving for y, so I can easily graph them in the calculator. This middle one here, I can see I don't have to do anything with it. It's okay. So my number 2 inequality is all right. I need to do a little work over here. So on this first one on the left, I'm going to divide everything by 5. And so that's going to give me 2/5 x plus 9/5. And I actually could express those in terms of decimals. It would be a terminating decimal. So I could say 0.4x plus 1.4, 1.8. So I could either use 2/5 x plus 9/5 or 0.4x plus 1.8. And then over here on my third one, and I'm going to need to leave this in the form of a fraction, I've got y is, we're going to divide everything by 9. So I got -2/9x plus 5/9. So jot these 3 inequalities down, because we're getting ready to move to the calculator and we're going to graph those, and hopefully I can see all the vertices without having to solve a system algebraically. I don't know. Jot them down real quick. All right, so I'm going to graph the 3 inequalities, and since I had just done this, let's see. My first one is 0.4x plus 1.8, and it's a less than, so I need to change that from a greater than. Well, let me go ahead and just clear all my equations out first. I mean, my inequality statements out first. Probably the best thing to do. Could do them one at a time, be okay. And let's change this from a greater than equal to a less than. Again, I highlight the whole thing. And I'm going to go down here and I want to change that to a less than or equal to. There it is. And let's enter our statement, which we said was 0.4x plus 1.8, or 9/5. And let's see, our second one is also a less than or equal to. So I need to change that from a greater than or equal to. My number 2, or my red graph. All right, there's the less than or equal to. And then the inequality statement was -x plus 6. And then let's move to the third one. It is a less than, so I don't have to change that. And it is -2/9 x plus 5/9. Now let's go to our graphing screen and let's see what we can find there. Okay, there comes number 1, there comes number 2, and there comes number 3. And my bounded region then is where? It's right in here. This little section right in there, where it's where all 3 meet. All right, let's see. 1 vertices, if I look at that, looks like x is -2 and y is 1. Appears to be right there. This one up here appears to be where x is 3 and y is 3. And then down here, looks like maybe where x is 7 and y is -1. But I want to go and look at my table and confirm all that. All right, so what did we say? I think we said, okay, look, where x is -2, the y1 is equal to 1 and y3 is equal to 1. There's a vertice. And we said, I think when x is 3, yep, right there, y1 is 3, y2 is 3. And when x is 7, y2 is -1 and y3 is -1. So my 3 vertices then are -2, 1, 3, 3, and 7, -1. All right, have fun with this.